Okay, well,
Yeah, we're gonna start class.
we probably have to get back on track.
We gotta get on track. We
You
don't have a
Off
lot today though,
trackers,
so it shouldn't be
off
too
trackers,
bad.
we got to get back on track.
Trackers. All right, who's praying for us today?
Uh,
Me or y'all? One of y'all? You guys are better at it.
I
Um,
can.
I think I saw a hand. Sub
I
teacher,
can.
Helper
go
of the
ahead.
sub
Help
teacher.
us with the sub teacher. Okay. Dear Heavenly Father, thank you for this day. Thank you for this opportunity to talk together and hang out and learn about math and have fellowship together. And thank you for Mr. Michael and for teaching us. And thank you for every opportunity you give us. In Yeshua's name, amen.
It was beautiful. Thank you. And yeah, so a little bit. If you guys did the Nearpod, this will be a little familiar to you. But if not, you'll be like still pretty familiar. It's kind of a little bit of review, but it's more, we've added exponents. So I want to go over that. And we're going to go back to equations at the end. And I'll try to keep this quick because we're running a little behind. But order of operations, we have parentheses, exponents, and now we're actually using exponents. So I wanted to show you what that's like with parentheses, exponents, and all the other orders. And when it's an expression like this, we actually go in order, the PEMDAS, we call that. So I'll be going in order and I'll deal with parentheses first. So we're going to deal with anything inside of parentheses, which in this case, 15 minus 7. That'll be the first step in solving this equation. And 15 minus 7 is 8. And we're going to square that. So 8 was what was in parentheses, and that exponent is still there. And of course, we're going to divide our answer by 4. So one step at a time. We did parentheses, then we do the exponent. And remember, the exponent 8 squared doesn't mean 8 times 2, it means 8 times 8. So this becomes 64 divided by 4. Anybody know what that is? Because I don't have a calculator. I think it's
wait, what?
16. I think it's 16, but that's just an estimate. Is that right?
Yeah, it's 16.
Okay. All right. I'm not good at once you go past 4 times 10, I'm like, it's a number.
I
I
can
know 4
do
times
like
11,
double
4 times 12.
digits in my head.
Yeah, if you can do double digits in your head, you're a genius. Like I don't know how people can
My
do.
my father's a math geek.
Oh, that helps.
Me
He
too.
is. He can solve
Mine
algebraic
too.
questions in his head. I'm like, how do you do all the algebra, like very long algebra questions in his head? I'm like, how do you do
Yeah,
that? You're not
I've
normal.
I've always had students like that too. Like
It's
I
just
thought
like
they were
I've
cheating because they would just be writing the answers down, and I'm like, "Where's your work?" And they're like, "I did it in my head," and I'm like,
like
"Mm-hmm."
how?
And then I would test them on it, and they really did. I'm like, "Wow, that's pretty
Wow.
impressive."
Like that is
Used-
like
I used to know somebody who could do like whole like my mom had this whole list of numbers that she needed to plus together. And then he just looked over her shoulder and said the answer is 2. And then he was only like 3 numbers off.
Wow.
Yeah, he was autistic, but he had like that superpower in his brain that he could
Yeah,
like
those like
yeah.
they
everything
call
out
like a
perfectly.
savant. Yeah, those people who can. There was a movie about that. It was really cool. Where this guy could do that. He would tell you like the answer to some crazy equation, but
Yeah.
he couldn't keep his life in order, but it's like he could tell you all this crazy math stuff.
Wow.
But yeah, so when we're following order of operation, parentheses always comes first. So we always do whatever's in parentheses first. Then, I mean, it's, of course, if it can be done. In this case, 6 minus 2, we can do that and just never get in the habit like when it's like I think because we read left to right, we always want to work left to right in math. But always follow that order of operation. So there is no exponent here, but there is a multiply. So we have to do that first. We have to do 3 times 4. A lot of people try to add 8 plus 3 first. So it becomes 8 plus 12. And that gives us 20. So as long as we're following order of operation, and these questions I made some to get a little bit trickier here. Um, that one's pretty easy. What would y'all get if you worked that one out? Who can do that in their head? I could actually do that in my head, surprisingly. 100 squared minus 5 times 3. You just got to make sure you do 5 times 3 first. But that's one of those hard ones. 100 minus 15.
Mhm.
Is it 85? I can't see through my. Oh, yeah. 85. Perfect. Who did that? It doesn't show me the name. Was that Lily? I'm just guessing. Yeah, okay, I can see her name. Whenever you write, it shows your name, but if you don't, your name goes away.
Purple. I'm the purple person. I'm always purple, and I don't think anybody else has ever had purple that
No, I
I
don't
know
think
of,
so.
at least. Hey, you had purple.
Uh-oh, where's my pencil at? There it is. Okay. No. Yeah, so questions like this, you got 6 plus 3 squared times 4. Always do the exponent first. So 9 times 4, and then we'll add the 6. So 9 times 4, 36. 6 plus 36, 42. And you guys know the trick with the nines? Like
Uh-huh.
if you hold down the
They all equal
fingers,
9.
like 9 times 4, if you hold down your fourth finger, it's 36. And like 9 times 5, if you hold down your fifth finger, it's 45. It's like it works on every single number. Like 9 times 7, 63. It's pretty cool how it does that.
Weird.
But yeah, so
But
let me
they
go
all
down.
equal 9. All the numbers put together. 36, 63,
Oh
72,
yeah.
81. They all equal 9.
I didn't realize. I was trying to figure out
And
what you're
also,
saying. I was like, what do you mean?
and also they always go up like stairs, that is what I think of. Like 18, 1, 8, 27. You take away the 1, and it always, the second digit goes down and the first one goes up. And that's how I remember it.
18, that's true. And then 27, 36,
See? 8, 7, 6. It would go
4.
to 5,
Oh, yeah,
4,
those all
3.
add up to 9. 8 plus 1,
And
2
then
plus 7,
the
3 plus 6.
first always goes up.
1, 2, 3, 4. Oh, yeah, I saw somebody do that vertically. And they did like 9 times 1, 9 times 2, and they did a list. And then they just started counting. They were like 1, 2, 3, 4, 5. And then they filled in the other numbers because it's like 8, 7, 6, 5, 4. Oh, yeah. That is kind of cool though, how you notice that pattern. How it's like 1, 2, 3, 4, and it keeps doing that. And
8,
these are like 8,
7,
7, 6,
6,
5.
5. And also like you get to 45, and so like 18, 27, 36, 45, 54, 63, 72, and
Oh, so
81.
like the numbers start to reverse. Oh, that's kind of
Yeah,
cool. Yeah, so it's like
a lot of 9
54,
tricks.
63, 72, 81. These numbers are just opposites of the other ones.
Mm-hmm.
It's like a mirror. I think we just discovered the secret to the universe.
And then 90, 0, 9, and then
Oh
9.
yeah. 90 is the opposite. 0990.
Yippee.
That's cool. I just learned a new math trick. 4 squared minus 6 all. And that one's kind of easy. Let's see. I'm going to skip down to a little bit harder one.
This is
Okay.
fun.
So now we're going to look at an equation with the order of operation is now backwards. Why can't I zoom? There we go. All right. My screen was like blocked up. So this one has just this is not one with an exponent. This is just order of operation goes backwards. Anytime we see the equal sign, I know that I'm going backwards. Instead of PEMDAS, it's now sad map. Now I'm looking for add or subtract. I would do that first. So whatever there are. And when we solve equations, we're always doing like the opposite operation. So this goes back to like those first few weeks because we're going to kind of come back to some of the equation stuff a little while. And now that we've added exponents, it kind of gives us an extra step that we can kind of figure out here. So order of operations in reverse. We add if there's subtract because we're trying to undo something that's been done. So now we have 4x equals 19 plus 5 is 24. And that's one of those. Now I've got a one-step equation where the number next to the variable, that always means multiply. So if they say 4 times x, we always do the opposite and we divide by that number. So that would give me x equals 6. So we're doing opposite operations. We're kind of going back to what equations were, except for now we're adding that extra step, that exponent. We didn't have to deal with that before, but now it's going to be just about the last step in our equation. So when we see an equation like this one, they put that exponent in there. I still follow the order of operation in reverse. So I look for add or subtract. There's not anything adding or subtracting. There is a multiply though. There is a 2 times x. So when you see an equation with an exponent, follow the order of operation in reverse. They multiply by 2. We do the opposite. So that ends up canceling out and just leaving me with an x squared. So 1x squared equals 32 divided by 2 is 16. So what we have now is we have an exponent. And we didn't do that earlier in the year. But now we have an exponent, which means two numbers that are the same. In other words, what this is, and a good way to look at this, x squared actually means x times x equals 16. So it has to be the same number that multiplied times itself to give us 16. So we got to think, all right, if something squared is 16, that doesn't mean something times 2. That means a number times itself. And when you start going through those numbers that work, like 3 times 3 gives me 9, 4 times 4 gives me 16, right? So the value of x would be 4. In other words, we would say x equals 4 because 4 squared equals 16. So when we're looking at which number to plug in for x, it's what number times itself gave me that answer right there. And you can always plug that in and make sure that it's true. Like, does 2 times 4 squared give me 32? Well, 4 squared is 16. 2 times 16 is 32. So we can always plug that answer in and just make sure that it actually makes sense, because if it's the right answer, 2 times 4 squared should equal 32. And if you work that out, it actually would do that for you correctly if you were to plug that into a calculator. All right, and similar down here, we have an equation where x squared minus 9 equals 16. We got two operations here. I got to get rid of subtract by adding. And that tells me that a number that was squared gave me 25. So the way we think of that is, okay, what number times itself? There were two numbers that multiplied to give me 25, and they're the same number. That's the key, is make sure that it's not just any two numbers. They have to match. So yeah, 5 times 5 gives me 25. So we know 5 squared would equal 25. Or x equals 25. Or x squared equals 25, yeah. So just figure out what that number would be that you'd plug in for x. And that's how we solve when there's exponents. So any questions on that? Exponents are not so bad. So I'll tell you here, You see a fraction in there. And I just wanted to kind of remind you guys, when you see something being divided, when you see a fraction, it just means divide, so don't panic. Order of operation is still in reverse here. I've got a fraction plus 6. X divided by 3 plus 6. Follow the order of operation. We get rid of that first. So I would get rid of add by subtracting. And that's telling me that x divided by 3 equals 14 minus 6, which is 8. So when you see the fraction in there inside of an equation, don't panic. It just means x divided by 3. We always do the opposite. So I'm going to multiply both sides of this equation by 3. And since those are opposite operations, they cancel out. And I'm left with x equals 24. So yeah, and I wanted to show y'all that before I showed you this one. This is a fraction, but there's also an exponent in here. Oops. Let me erase this. There we go. Why can't I zoom? There we go. All right, so this one has an exponent being divided by 5, and it has a plus 4. Keep it simple. Always do one step at a time. Order of operation is still going backwards. Don't let fractions inside of an equation throw you off. We just take it one step at a time. So if they add, we subtract. So they added 4, we subtract 4, we're getting rid of that. We're left with x squared over 5 equals 9 minus 4 is 5. So we did one step. Now we've got to get rid of divide by 5. So if they divide by 5, we multiply by 5. And this gives us another one of those pretty easy exponents to solve for. Now we're left with x squared. So once I multiplied by 5 on both sides, it got rid of that denominator, and it left me with x squared equals 25. And just like Lily said over here, 5 squared equals 25. And
That
you'll start
wasn't
figuring
me.
those out.
Someone
Was that
stole my color.
someone stole your purple color? Should have known that
Uh,
wasn't you. That 5 looks suspicious.
Yeah, it's too straight. I don't draw good on a computer, don't you know?
Ha ha ha! I've
Tell
stolen your color.
someone can draw their 5s really good. We used to have this drawing we would do with a 5, and I can't remember what it was, but it was like you made it look like a person somehow. It was like you made a hat, and I don't know.
Yeah, that's how I teach
There was
William.
something we used to do with
I
it,
gotta
and it's
get my thickness back.
been like 20 years.
So there's his hat, and there's his back, and there's his big old belly. And now when William draws it, he can't do it without putting a belly button on it. And the 4 is an upside down chair. And that's like the only way that I can teach him is if I tell him the 5 has a big belly.
Oh, you should be the substitute teacher. I keep forgetting what 5s
Me?
look like.
Why me?
Let me see. Okay. All right. We're going to go ahead and do some review games. Lily, do you have your game for us to play?
Oh,